Hi folks, for this video we're going to focus on geometric sequences. So in the first place, let's get started with the definition of geometric sequences. What does this guy mean and how does this guy function? Geometric sequences is a sequence of numbers where each term after the first is founded by multiplying the previous one by a fixed non-zero number called the common ratio. This definition is probably kind of complex because it is from Wikipedia, but we can simplify it and we can examine this definition and we can assume the previous term to be un. And if the common ratio is r, we can arrive at one of the most basic characteristics of geometric sequences. Examine the definition, pause the video if you want, and probably you can come up with a formula. Yes, what we got is un times r equals un plus 1. This formula is really significant because from this formula we'll be able to derive equations that applies to not only un and un plus 1, but also generally all terms of the geometric sequence u. So from this equation we can do some derivations that are essentially derivations of it. So if we sub in n plus 1 to the place of n plus 1 is going to tend to n plus 2. So we're going to get un plus 1 times r equals un plus 2. And we can mark the original equation as equation 1 and this equation as equation 2. And we can do the same thing to equation 2 as we sub in n plus 1 again to the place of n, and we can get un plus 2 times r equals un plus 3. And when we sub equation 1 into equation 2, we can have another equation. So we can equate un plus 1 to un times r and sub it into equation 2. So we're going to find un times r equals un times r squared equals the right hand side un plus 2. So this equation, I'm going to repeat it, un times r squared equals un plus 2 is the new equation. And now we can even sub in equation 3 into the new equation, and we can find un times r to the power of 3 equals un plus 3, and so on. Now we can clearly identify a pattern. If you didn't, pause the video and take a closer look at it. Yes, the pattern we have discovered is un times r to the power of k equals un plus k. If we assume n to be 1 and k to be n minus 1, what can we find? Pause the video again for a couple of minutes if you haven't found the pattern. Yes, what we've got is un times r to the power of n minus 1 equals un. It is, from my perspective, one of the most significant formulas for geometric sequences. So that is all we're on today. Remember to leave a like if you liked the video, but no patrons. Thank you, no patrons. At the end of the video, there's one challenge question. How can you deduce this formula? Un minus k times un plus k equals un squared. If you can, please leave your procedure down in the comments. If you liked the video, leave a like. It's going to help us out greatly. Thank you for watching. Goodbye.